Speak Student!
Astronomy, Part 5. Stars. And nothing to do with Hollywood. How is a star formed?
Some of these clumps that form in the universe, some of them are really, really heavy, and some of them are not so heavy. And anything that's heavy enough to start forming these nuclear reactions will turn into some kind of a star. First it becomes like a proto-star, which is just like a baby star. And then, if there's enough mass, it will actually form a normal star, what we think of like the sun or something like that. And if it's a very light clump, then it'll form something like an M dwarf. This is like the most common star out there in the galaxy. And they're, more red, and they're pretty tiny, and there's a lot of them around, but it's even hard to see them from the Earth because they're so dim. And the heavier stars become closer and closer to emitting blue light. So the sun is white hot, and stars that are way heavier than the sun will be blue, and this is just really, it's a consequence of their temperature. So the hotter they are, the more blue that they will be, and the colder they are, the more red they will be.
Got it. And that's the color we see them at, or is it a reflection of the gas that they're burning?
That's the color that we see them at, and more so than being a property of what the star is made of, it's how hot the star is.
What is the lifespan of a star?
When they form, they're of a certain type, and they're relatively stable on the course of, a few billion years, something like that. And some stars, the really, really dim ones, the ones that are very red and small, their lifetimes are something like 20 billion years. So that's way older than the age of the universe.
Yeah.
Stars like the sun they'll last for about 8 billion years or something like that. And heavier stars, like I was talking about the first generation of stars, they don't live very long at all, like a couple 100,000 years. The crux of the issue here is fuel. So stars burn through fuel. Right now the sun is burning hydrogen into helium, and in this nuclear fusion process.
So wait, what does that mean? It burns hydrogen is one atom and helium's two? So how does it do that?
So it will actually, it's so hot in the middle of the sun that the particles are moving so fast that they can crash into each other, and you'll actually have, two atoms, smaller atoms coming together, and they crunch and they stick together, and they form this new heavier nucleus, and in doing that they kind of free up some energy that gets spit out, and that's the actual
Got it.
light.
So that's how hydrogen becomes helium.
Yeah.
Got it. Okay.
So this process happens, and this will continue on in the sun for a very long time. But one of these days it's going to run out of hydrogen, and when it runs out of hydrogen, then it kind of starts this process of puffing up and becoming this red giant and stuff like that. So when the sun actually does this is interesting. It'll puff up enough that it'll engulf the orbit of Mercury and then to Venus, and we think it'll also swallow up the Earth. But
And why does it puff up? Because it's only helium, and helium expands. Like, that's the thing you stick in the balloons and then you inhale it.
It makes you talk like a Disney character or something. Well, it puffs up because it doesn't have it becomes less dense, and it gets...
So there's not so much enough gravity to pull it into these tiny...
Got it.
So it's more about that, the density. But so then the helium will burn, and that can burn and becomes things like carbon and nitrogen and oxygen and stuff like that. Eventually we reach the most stable element of all is iron. And the sun is actually not heavy enough to burn iron, but more massive stars will eventually get to this point of, they can burn iron, and this is an incredibly unstable process. Once you get to the heavier nucleus nuclei that you go to, you get less and less stability there. So, the sun can burn hydrogen for like 8 billion years or something like that. But the iron burning lifetimes of these very, very heavy, massive stars are like less than a minute. And what happens is they burn through all of the fuel that they have, and there's nothing, they're left with this big void in the core of the star. And basically at this point, the whole thing is kind of like this shell that's totally has nothing on the inside to support it. And so it all comes crashing in together. If it's a heavy enough star, all of this stuff will come crashing in together basically at the speed of light, because there's so much gravity there, there's so much mass. And when this happens, it'll come and it'll collapse together, and then it'll send this shock wave out of, a massive amount of debris, and we call this a supernova.
Wow, that's cool. So what's just a nova?
Just a nova is actually the same thing. Supernovas get all the press, but
Yeah, it's like
novas are
upgraded.
out there. There are novas out there too.
Wow, okay, so it comes in and explodes, and then there's just a bunch of gas and particles that just kind of slowly fade away and go into oblivion?
Well, there's this big kind of expanding portion and stuff like that, and you might have some kind of remnant. At the middle, you'll get a white dwarf star, which is this very hot thing that's just a remnant of all of the stuff that was left after it spit out all of it. And if you have a really, really massive star, like, 8 times the mass of the sun, or maybe 10 times the mass of the sun, then the gravity can actually become so strong that you'll form a black hole.
Got it.
And so this is the famous, Stephen Hawking's famous for he explained a whole bunch of things about black holes and stuff like this. And what black holes are is basically, they're so dense, there's so much gravity there that nothing can escape, not even light. And so you can't see a black hole. It's just a,
We know it from all the stuff that's going on around it, and we think we've identified an area maybe that we want to stay away from.
Yeah, right. You don't want to go near one. So we have one in the middle of our galaxy, and it's something like it's a couple million or 100 million solar masses.
Wow, okay, that's big.
It's real big.
More than my golf ball. How are stars created? Differently from planets? What are red dwarfs, white dwarfs? Hi-ho, hi-ho, it's off to work we go. What's the lifespan of a star? What happens to a star when it dies? What is a supernova?